Okay, friends, in this video we'll discuss flux. What is flux? In fact, electric flux. Okay, flux can be of many type. We'll talk about electric flux. So, flux is a measure of number of field lines passing through a cross section or an area. एक क्रॉस सेक्शन से कितनी फील्ड लाइंस पास होके जा रही हैं वो फ्लक्स है. ओके, तो E is basically number of area per number of field lines per unit area. तो जब उसको एरिया से मल्टीप्लाई करते हैं तो आपको बेसिकली नंबर ऑफ फील्ड लाइंस मिल जाती हैं जो कि फ्लक्स बताता है. ओके, तो मान लेते हैं ये एक पूरी बड़ी सी ऑब्जेक्ट था, उसके ऊपर आपने एक छोटा सा एरिया वेक्टर लिया. एरिया वेक्टर इज ऑलवेज आउटवर्ड नॉर्मल. ओके, एरिया वेक्टर इज ऑलवेज आउटवर्ड नॉर्मल. So let's say electric field at that small area vector is like this and D is outward normal to the surface. जैसे अगर आपको इस जगह का एरिया वेक्टर रखना है तो ऐसे हाथ रखेंगे एंड थंब विल गिव यू द डायरेक्शन ऑफ आउटवर्ड नॉर्मल एंड that will be the direction of area vector. So the angle between E and DA vector is theta. So small flux will be E dot dA or E dA cos theta. We can say that integrating this small flux over the complete surface will give me the total flux. Okay, if E is uniform, then we can say the flux through the surface is E dot A. Just integrate किया एंड डी का इंटीग्रेशन ए आ गया क्योंकि ई और थीटा कांस्टेंट है, तो ई ए कॉस थीटा और ई डॉट ए इज द फ्लक्स थ्रू एन एरिया इफ फील्ड इज कांस्टेंट. अगर फील्ड कांस्टेंट नहीं है तो यू हैव टू इंटीग्रेट दिस. ओके, रिमेंबर इफ फील्ड इज नॉट कांस्टेंट you have to integrate this, and if it is constant you can take directly dot product between E and A. मोस्टली क्वेश्चंस यूनिफॉर्म फील्ड के ही होते हैं. फाइंड द फ्लक्स ड्यू टू अ यूनिफॉर्म इलेक्ट्रिक फील्ड थ्रू अ डिस्क एरिया ए इफ एंगल बिटवीन डिस्क, अगेन एंगल बिटवीन डिस्क नॉट इट्स एरिया वेक्टर, इज 90 डिग्री. तो पहला केस बनाते हैं हम. मान लेते हैं पहला केस कुछ इस टाइप से है. दिस इज द डिस्क एंड दिस इज फील्ड. एंगल बिटवीन डिस्क एंड फील्ड इज 90, but this will also be area. So in this case theta will be 0, hence the flux will be maximum EA cos 0 which is EA. केस बी देखते हैं. केस बी में वो बोल रहा है that this is basically angle between surface and field is 0, so the field will be parallel to the surface, but again as area is normal to the surface, in this case angle will be 90 degree. Again this is the angle with the surface, not the angle between area vector and this. In this case angle between area vector and field is 90, so flux will be 0. You can remember whenever field is parallel to the surface, flux will be 0. Obviously if field lines are parallel to this page, no field line will able to cross through this page. Okay, so C is angle between surface and field is 30 degree. This angle is 30 degree. This is field, this is surface, but angle between area vector and field will be, which is theta, will be 60 degree. So flux will be EA cos 60 means EA by 2. Okay, that will be the flux. In the next question, there is a uniform electric field given by 2I, 3J and K. We have to find the flux through a sheet of area 100 meters square if the sheet is in XY plane. Okay, just look at this diagram very carefully. This is X, this is Y, and this is Z. If the sheet is in XY plane, obviously the area vector will be towards Z axis. So in case 1, we can write down area vector as magnitude and direction is k cap. So flux will be E dot A, and that will be 100k. Oh, this dot this will give me 100 unit. Similarly, when the flux, when the sheet is in YZ plane, this is YZ plane. So the area vector will be towards X, normal to it. So in that case, area vector will be 100, direction is I cap. And when we take their dot product, E dot A, आपको डॉट प्रोडक्ट लेना आना चाहिए, तो this dot this will give you 200. I का I के साथ होगा और J और K इसमें 0 है तो वहाँ 0 आ जाएगा. Similarly, C area vector will be 100 J cap and flux will be 300 unit. 100 into 3J will give you 300. In the next question, we have to find flux passing and net flux. These are the two different things being asked, flux passing and net flux through each body. Okay, net flux is 0 whenever field is uniform. E is uniform. Okay, net flux through a three-dimensional object or closed object must be 0 whenever field is uniform. So in all these cases, field is uniform, so the net flux is 0. So basically, we are asking flux passing through each surface. Whenever field is uniform, for flux passing, we can take the area of the shadow. Okay, so let's take first example. In this, all the cases will have a projection of circle. All the cases will have projection of circle whose radius will be r. So the area that will be covered is pi r square. No matter it's sphere, disc, cone or hemisphere, the area of the shadow will be this. So the flux passing will be E into pi r square. Similarly, in this case, the shadow will be formed as a triangle with base 2r and height h. So the area of that triangle will be half into base into height, that is RH. Hence the flux will be E into RH. In this case, E is parallel to Eitjee and AC. AC and Eitjee means phase diagonals के parallel है field. तो जो area of the shadow बनेगा या इस पूरे क्यूब की जो प्रोजेक्शन आएगी वो ध्यान से देखें. ये जो अभी मैंने प्लेन बनाया है ये आएगी. इनको ज्वाइन करते हुए जो प्लेन बनेगा वो शेडो क्रिएट करेगा. तो इस प्लेन का एरिया जो आपको दिख रहा है, ये एक प्लेन है रेक्टेंगल, जिसके एक साइड ए है और दूसरी साइड √2a है. ओके, ये साइड √2a है. तो हम बोलेंगे एरिया आपको दिख रहा है a इंटू √2a, √2a स्क्वायर. hence the flux will be E into √2a square. Okay, thank you.